Video lesson 10.3, simple interest and compounded interest. So today we're going to talk about two types of word problems that are dealing with interest themselves. So simple interest is what you would normally see at your standard bank. It's interest that's calculated through over a year at an interest rate, and it's just is the simplest version that you can take when dealing with it. So if you look at example 1, here, Kara's been babysitting since 6th grade. She has $1,000 and wants to open an account at the bank. She'll earn interest on her savings. So simple interest pays at a rate of 10%. So the question says, how much money will she have after 1 year? So we just want to calculate how much that money is going to grow in that savings account. All right, so if we take here, right, our rate, which in this case R is 10%, we'll convert it to a decimal. And we're going to just simply multiply that by whatever value she's plugging into the bank. So it's going to be $1,000 times that 10%, which means she's going to make $100. So that's how much she's going to earn, right? This is her interest in this case. All right. So if it's saying how much money will she have, you have to then take, that would be referred to as her total amount, would be the initial amount or the principal plus the interest, which was 100. So that means altogether she has $110 when she's done. If you do that after 2 years, if she does not add any more money to the account, so we're assuming she just put the $1,000 in and that was it. So that means she's going to earn another $100 for the following year. So simply say, you can just simply say the $100, right, times 2. So now after 2 years, she would have earned $200, right? So she'd have $1,100, and then an additional $1,100 after that. I'm sorry, the additional 100 to that. So that would give you a grand total of $1,200. So again, for 5 years, we could do the same concept. If she did this whole process for 5 years, then she would be getting $100 each year, which would be $500. So therefore, 1,000 plus the 500, she would have made $1,500. So that's the idea. That's simple interest, right? You're accumulating the same interest or value over that period of time. So in here, we have a formula. And let's go here. I equals PRT. And it's all multiplication. P times R times T. Principal. Let's label some of these. P for principal. Right? And that's the principal is how much you start with. We've got R is our rate. And as we know, we need that in the decimal form. We've got T, which is time. I'm going to do it over here. The one thing to notice in this one, time is in years. And then, of course, the I, which we start off with, is interest. It's how much you're going to accumulate over time. Okay. So that's all each of these are done for. Right? So, again, a little thing to note, and I have it right here, is it's good to know that this formula only calculates the interest earned. So if you want to find out how much you have or the total amount, you have to go back and plug it in. So over here, your total amount equals your principal plus your interest. So if you're looking for that value, you're going to have to take an extra step and go back, find out what the original value was, plus whatever you calculated the interest to be, and that'll give you what you have. So it's all about labeling. Let's take the time to kind of go through this and figure out each of these things. So for here, I see that amount of $2,000 invested, 15 years trust fund that pays 6.5% annual simple interest. So the second I know simple interest, off to the side, I equals, P equals, R equals, T equals. Fill in what I know. So we're looking for the interest. So I'm looking for I. P is 2,000. Here's how much I invested in a 15-year trust fund. So T is 15, and the rate was 6.5%, which we had to convert to a decimal, get rid of the percent sign, scoop 2 places to the left, so it's going to be 0.065. So we're looking for here that interest, so let's calculate it. So I is going to equal 2,000 times 0.065, and I'm going to multiply that by 15 years. So now if we go into our calculator, we calculate that to be 1,950. So that's the interest. That's how much they've earned over that period of time. But the question says, what's the total amount? So now if I want that, I'm going to abbreviate here, TA for total amount. That's going to be our initial, which was 2,000, plus the interest we just found of 1950, which gives a grand total of 3,950 for what they made. So $3,950 is the total she'd have after that amount of time. Now, that's wonderful if that interest is growing at that rate over time, over that many number of years. But the another version of interest is called compounded interest. And that's where the period of time that is the money is growing or you're accruing interest, it's calculated at different periods during that year. And then you're also being either making or being charged interest on the money that you're making as well. All right, this is what you see for like credit cards and other types of loans that allow your money to either grow a little quicker, or in certain cases like a credit card, you have to owe them a little bit more. They're making money for them. All right, so this is it. It looks a little intimidating at first, right? Here, this formula right here, but it's really not as bad as it looks. So let's just break everything down first. So A is the accumulated amount. That's how much you're going to earn over the period of time. P is still principal. All right, P is still principal. So that's this part. Your R is still your rate. So that didn't change. R is still your rate. Of course, is a decimal. Now, the other part that's a little new is the N. That's the number of compounded periods per year. So that's how often it's occurring. That's what these are here. So like if N is 1, that would be yearly. So like quarterly, that means 4 times a year. So N would be 4. Monthly, N would be 12. You could do daily, which would be 365. You could do bi-monthly, which would be twice a month. You could do, a variety of different things, but these are your common ones here. All right. And last but not least, we also have years for T. So that part there. So really the only added thing here is this N, and how much. That's just, again, how often it is being calculated over the course of that year. All right. So let's look here. So if you go back to that first example with Kira's babysitting, right? If we think about that. So she had $1,000, right? Then she made 10%, which was of that 1,000, which was 100. So she had $1,100 after the first year. And after the second year, she made another $100, so that would be $1,200. Well, if you calculate with this compound, if I now take the 10% of this new value for the second year, she made $1,210. So she made a little bit more, an extra dollars, by using this compounded interest concept. All right, and that's how it is. It's applying the percentage for each period of time to the previous amount just created. So that part's going to keep growing upon itself. All right, so let's look at this one here. All right, so we got Maria's parents invested $14,000 at 6% per year compounded monthly. So once I know that, I know it's a compounded interest question. So we can go off to the side. We can find out our pieces. So A equals P equals R N and T. So we know here, let's see, what do we know? We know the principal is 14,000. The rate is 6%, which we're going to put as 0.06. N is compounded monthly, so that's 12 months or in a year. And time is 10. So let's plug in our formula. A equals P times 1 plus R over N, all raised to the NT. So we'll plug this information in. We've got 14,000. We're going to multiply that by 1 plus, we can get 0.06 divided by 12. And that's going to be raised to the 12 times 10. All right, so now I recommend doing this in pieces, trying to not do everything in one shot into the calculator, because that usually causes some problems overall. So let's go through this though. So it's got 14,000 times, let's see, 0.06 divided by 12 plus 1. That's going to get me 1.005 raised to the 12 times 10 is 120. Now I'm taking this number. Here you got to just be careful. Again, follow your PEMDAS rules. I have multiplication and exponent. Do the exponent part first. So 1.05 raised to the 120. And then we're going to multiply that answer by 1,400. And when I do that, I get a value of 2547, and it's money, so we're going to round it off nearest cent. So I get $2,547.16. Now, notice one other thing that's a little different here is that when doing this here, oh, you know what? I just realized hold on a second. Sorry, I put 1,400 instead of 14,000. So let's just go back and make that adjustment. So that would be 25,471 and 55 cents. That makes a little bit more sense. All right. Notice one big thing about the difference in these formulas is that when you're done here, that's everything. This is the principal and the interest combined. All right, that's everything all together. I don't have to go off and find the total amount because it's already calculated. The A is the cumulative amount earned, because you're taking that 14 and you're applying that rate, and then you're doing that to the new amount each time, each period. So in this case, each month, you're taking that little bit that's been added and you're calculating it in. So it keeps growing. So you're done once you find the calculation. All right, let's look at example number 4 here. So Paige invested $1,200 at an interest rate of 5.75 compounded quarterly. So again, here we go, quarterly. So once I see that, I know it's a compounded interest question. So I want to find these 5 pieces of information. So invested, that's my that's what we've invested here. So that's my principal. So it's 1,200. we've got a rate of 5.75%, which is a decimal is going to be 0.575 because again we're scooping 2 places to the left. N is our how many times is occurring within the period, so that's quarterly, so that's 4. And for this one, it's being done for 7 years. So let's calculate this. A is equal to 1200 times 1 plus 0.0575 divided by 12. And then that's all raised to the 12 times 7. All right. So once again, now we're going to plug it in to maintain your thought process. So again, I like to kind of start in the middle here. So I'm going to do the rate, divide that by, not 12, should be 4. Right? Divide that by 4. I'm going to add 1 to that. So that's going to look like this. Not a very nice short decimal. And we're going to raise that to the 28th power. So let's do that. So we're going to raise that to the 28th. Then we're going to multiply by 1200. So I get, whoops. So I get $1,789.54 for that one. So that's it. All right, that's the idea. That's how you produce that compounded interest. Again, it doesn't matter what the interest rate, or changes, or the amount that you invest changes, or the compounded part. Like, you just need to plug them all in appropriately. Again, the compounded portion is the one you got to be the most careful about, and that is, in determining how many times it's going to occur within the period of time of that year. All right. So this one here, Brooks is saving money for a trip to Bahamas. That costs $295.99. She puts $150 in the saving account that pays 7.25% interest compounded quarterly. Will she have enough money in the account after the 4 years? So let's see. Let's plug in what we know. We know we've got she's investing $150 at a rate of 7.25%. So let's scoop. So it's going to be 0.0725. We've got a let's see, compounded quarterly. So again, that's 4, and we're doing this for 4 years. So A is going to equal 150 times 1 plus 0.0725 over 4 raised to the 4 times 4. All right, so let's take that rate divided by 4, add the 1. So we get 150 times 1.018125 raised to the 16. So then actually raise that to the 16, multiply it by 150. I get $199.94. So now I just got to make sure I go back and actually answer the question, which says, will she have enough after the 4 years? Explain. So the answer is no. Brooke will only make $199.94 at a rate of 7.25% compounded quarterly. Therefore, she will not have enough to pay for the trip that costs $295.99. All right, so that's the idea. And then the only other thing that could occur, and sometimes does, is that they could give you the accumulated amount and ask you to find one of these pieces. Nothing excessive, just have to do a little extra algebra to kind of calculate that. A more common one would be finding the principal at this rate, at this time right now. But you could actually be asked to find other things. But again, realistically, at this stage, if you're going to have that, it might give you what A is and ask you to find P. Again, just plug everybody else in, simplify as best as possible, and then, again, isolate the variable that you're looking for to solve. All right, take the opportunity to look the video over if you have any other questions or need a little bit more practice on it. And don't forget to utilize the practice problems for extra help.